Welcome back to another tutorial. This is the third part in my three-part series where I basically go over the basics of Onshape for beginners. And today we're going to be focusing on the assembly, which is a whole section of Onshape that allows for a bunch of crazy things to be made. It allows you to actually animate the different parts you make in your part studio and your sketches and see how they could actually come to life. So yeah, it's pretty cool. So the first thing you want to know about an assembly is this little insert command right here. So basically what this does is it allows you to insert stuff from your part studios, different assemblies you might have, or even other documents. So for this video, I'm just going to be sticking with showing you guys how to insert from different part studios you have. So let's start by clicking on it and clicking check. So as you can see, we have our two parts inserted into our assembly. Now this is different than the part studio. So basically what you do is you go over to your part studio, you make your parts using your different sketches and extrudes, and once you're happy with it, you can import them into your assembly, and then you can test how they interact with each other. So there's like a bunch of different tools at the top, and I'm going to be going through the main ones that I use and I personally find the most useful. So the first thing you got is this mate connectors here, and as you can see I already added some on here, but basically what they do is they're like little points that you can use as reference for all these other things. So they're actually pretty important. So they might be kind of confusing if you've never used one before, but as you go through these you'll start to understand. So we're just gonna not worry about that right now. So the first thing we're gonna do is a fastened mate. So I have these two parts here, and I want to somehow make it so they snap together, and I want to test if they're going to fit. So one thing I could do is use a fasten mate, or use the M command on my keyboard, and it's going to say choose your mate connectors, choose one, choose two, and right now they're intersecting, but I can just flip the primary axis and click on check. So just like that, we have the two parts intersecting with each other. Now, if we want to make sure that they're not intersecting or interfering with each other so that there's any issues, we can just right click and choose check interference. And as you can see, it lights up blue, meaning that everything is good. So also in this fasten mate, you might notice some of these offset commands, which basically just means if you want to space it out or space it out like, so say you need to like spaced out a certain amount, you could just use the offset command. Yeah, this is pretty useful, but yeah, it's pretty basic. So one main application of this would be like for screws on doors or something like that, where you basically want something to not move. That's where you would use a fasten mate. So yeah, moving on to the next mate. This one is called revolute mate, and what this one allows you to do is only rotation. It doesn't allow any sliding. So I'm going to show you how to work one. So you can use M again on your keyboard, or just select it from the top here, and I'm going to choose the bottom and the bottom here. So now we can see if we move it right now, it's kind of moving, it's not moving how I want it to. So I'm going to fix this part in place. So now the only thing that can move about this is our revolute mate, which is basically just this little part spinning at the top, which is kind of cool. So now there obviously is some things you can change in these settings, like if you want to offset this, you can, or if you want to add a limit so it can only rotate a certain amount, you can also do that. But yeah, this can be used for many different applications, like I would say a door is a great example. So say you wanted to make sure that the actual turning mechanism on the door wouldn't interfere with anything, you could add a simple revolute mate and check if everything was working correctly. But yeah, the next thing we're going to focus on is called a slider mate. And a slider mate, basically what it does, it allows for sliding only, no rotation. So it's kind of similar to the revolute, but also different. So I'm going to choose the slider mate, choose this face, and I'm going to click check. Now I'm going to fix this outer blue part so it stays still, and the only degree of freedom this has is to move this slider mate up and down through the thing. Now, as you can see, you might want it to stop here or stop here, and there's an easy way to do that. It's called by adding a limit. So in the limits, you want to make sure that this bottom one is always bigger than your top one. So if we click on check, you can see here that now when I move it, it moves down, but doesn't go any fast, and then it won't move any more up. So yeah, that's just this kind of simple trick you could use. Okay, next one. The next one is called a planar mate. And basically what the planar mate does is it allows for movement on a flat surface. It can slide and rotate, but that's about it. So I'm going to choose the planar mate, choose this face, and I'm going to flip the primary axis. So now it might seem like it's just kind of moving all crazy, which it is, which we need to fix this so that it stops moving crazy. So it might seem like it's moving just like nothing's really controlled, but if you look at it from the side, it is always staying on this plane. So it's always staying level with this plane, which could be useful for a bunch of different things. Like say you wanted something to slide across the table and without moving or something like that. You can kind of think of it like a book. So it's kind of like the table's the one face and your part's the other face, and they just are constantly staying parallel. So yeah, I don't really know if that was a good example, but yeah. So say you wanted to add some limits to this, you could easily do that. So you want to limit the Y and the... So now as you can see, this part, it can now only move like this, which is kind of cool, and you could use it for a bunch of different things. Moving on to the next one, which is called the cylindrical mate, which is very similar to the revolute mate and the slider mate. It's basically just a combination of the two. So what the cylindrical mate does is it allows for rotation plus sliding. Sorry, I was just looking for the words there, forgot. So we're going to select these two, and if we fix this blue part, and sorry if it's unclear about how I'm fixing it, basically what I'm doing is I'm clicking on it, right clicking, and then there's just this little fix thing that I'm choosing. So now what this thing can do is the cylindrical mate allows it for to move up and down, but it also allows me to rotate this part. Sorry, it's a little bit laggy from all the different part studios I have open. But yeah, this could be useful. Say if you needed to push something out and then turn it, like this little thing right here, or you had a gear on the end and you wanted to push the gear in place and then you wanted to turn the gear, it could be useful for something like that. This is probably one of my favorite ones to use, but yeah, it's really simple. Moving on to one of the more complicated ones, it is going to be the pin slot mate. Which what a pin slot mate allows, it allows for sliding in one direction. So we basically want, this basically turns circular motion into like forward and backwards motion. So I kind of created this little contraption, and I'm just going to create some restrictions so that everything, I can show you how it works. So I first just fixed this main plate in place. Now I'm going to choose my revolute mate. So this one's a little bit more complicated since you have to combine some of the things you previously learned. So we're going to choose this face and this face. So now this part will move in here. Now I want to add another revolute mate between this face and this face. And I'm going to click check now. And now you can see when I move this, it moves this, and it can move like that. Now I want to do the actual pin slot mate, which for the pin slot mate, you can just choose it. And first you want to click on this thing right here. Okay, so then you just want to click here and click check. And now if we rotate this, you can see that it is working. This looks pretty cool. So you can see that if I rotate this, it moves this side to side. So that is going to be the pin slot mate. Now this could be useful for making some cool fidgets. No, I'm just kidding. It could be useful for a bunch of different things, like they have these kind of mechanisms in cars and stuff like that. Okay, next mate is going to be the ball mate. Now this one is much more simple and straightforward. So the ball mate, all it is rotating a ball in like an outline. So we're going to click on the ball mate, we're going to click on here, here, and click on check. Now I'm going to fix this outer rim, and now you can see it allows for this to move like a ball, basically. And this is basically going to be useful for things like these joysticks here, or yeah, just basically like these joysticks. That's basically the only thing they're good for. That's all they're good for. No, I'm just kidding. They're good for other stuff too. But yeah, it's pretty simple, this one. Yeah, nothing too crazy. Okay, next one is going to be the parallel mate, which the parallel mate is a little bit confusing, but it is also kind of useful. So the parallel mate is more, you click on your two parallel faces, and now when you move one of them, these faces that you clicked will stay parallel to each other. So say I rotate this, the two will stay parallel together. So this could be good for things like a robot arm. Like a robot arm. Let me find my robot arm picture. Oh, I didn't open my robot arm picture. Like a robot arm like this, where this flat part needs to be flat the whole time according to the base or the earth. And yeah, that's basically something it could be used for. But yeah, okay. Next one is going to be so those are basically all the mates. So those are what you use to connect parts and make parts interact with each other. But there's a bunch of other things in this assembly tool that need to be explained. Like, for example, this group tool. So let me just kind of show you. So say I insert something like this, and I need them all to stay together. Like, I don't want them to move individually. I can just highlight everything and choose the group tool, which this one is pretty self-explanatory. Now they all move together. But when I first started out, I couldn't find out how to do this. I was like right-clicking. I was like, where's group? Where's group? But turns out all you have to do is just click it from up here. So yeah, that is pretty helpful. Now you have this snap mode and show mates. So these can be a little bit tricky to understand, and I still don't fully understand snap mode, to be completely honest. I get it. It's basically like it automatically snaps your parts together based on the mates you add in the part studio, but it doesn't really make too much sense to me. But I'm gonna show you what the show mates do. So say for this one I add a bunch of revolute mates in here, and I can now just show where the mates are. So it's showing me that I have no mates, which is very helpful since I don't have any mates. Yeah, didn't really need to explain that one. And then the next tool is going to be the linear pattern. Now, linear pattern is the exact same, the exact same as you would use it in Part Studio. All you do is just choose your instance and your direction, and now you can create a bunch of these in a row. Yeah, it is it's very useful, but very basic. Next one is going to be your cylindrical pattern, which is the same thing, except you can basically just extrude them in a pattern instead of a straight in a circle instead of a straight line. Sorry if you noticed that I am slurring my words. It's because it's late at night and I am tired. So the instant, we could just change this, and yeah, it just kind of adds a bunch of circles in a circle. Bunch of parts in a circle. Okay, getting near the end. The next one is going to be the mirror. command, which again is very self-explanatory, very simple. You choose the face that you want, or the instance, and then you choose your mirror plane and it mirrors it. This is useful if you need to make parts that are symmetrical or just making things in general. Okay, the next one. Now these next two are probably my favorite two to use, and it's the gear relation and the racking pinion. So starting with the gear relation. So I am going to insert this little gear assembly I made here. And I made a whole video where I basically broke down exactly how gears are made in Onshape and how you can work with them, and they're pretty simple once you understand a few key things, but I made this little contraption here. But right now, if I want to turn the gear, it just works like, just doesn't work, to be honest. So the first thing you want to do with one of these is you want to fix your base. So fixing the base, now I'm going to choose a revolute mate, and once it stops lagging, choose this bottom part here, choose here. Now click on check. Next one, I want to do a revolute mate on here and here. So now these spin individually, but they don't interact with each other. So that's what we're going to try to fix right now. So we are going to choose our gear relation, and we're going to choose these two revolute mates that we created before. And now it's going to ask for our gear ratio, which is, for me, in my case, going to be 2. And you might be saying, oh, how do you know it's 2? All I do to figure out my gear ratio is, you can see here where I create my gears. My gear number 1 has 25 teeth. My gear number 2 has 50 teeth. So I take 50, I divide it by 25, and it gives me 2. So that's how I know my gear ratio needs to be 2. And once I make it 2, you can see that the gears now mesh together nicely. And that's pretty simple, and it can be helpful to just make sure that your gear ratios are correct and everything's going to work as you want. But it can be very cool to see things that actually come together and work. And the final thing that I'm going to show you in the assembly thing is going to be the rack and pinion relation, which is a very kind of complex relation, but it's also pretty cool. Like, most of these are actually pretty cool. So I'm first going to create first I'm going to fix fix the base, create a revolute mate between this gear and this little peg. Now I need to create a slider mate. So I'm going to create a slider mate between the corner of this and the corner of this. Boom, check. I actually want to, no, actually that's good. So now I'm going to, I can just kind of rotate this and kind of line it up. And now it's going to say choose your mate. So I'm going to choose my revolute mate and my slider mate. And now it's going to say choose your distance per revolution. Now to find your distance per revolution, you want to come over to where you created your gear, and there's going to be this little circle on the outside. And that is otherwise known as your pitch diameter. So my pitch diameter is 48. So with that number 48, I'm going to come back into here, and I'm going to do a bracket 48, and I'm going to do this little star, which means multiply, and I'm going to multiply it by pi. So 3.1415, that should be good. And click on check. So now you can see that they're moving in opposite directions, which is an easy fix. Double click reverse direction. Boom. And now you can see they're moving together. So yeah, that is basically how you make a rack and pinion relation in assembly. And that's basically all there is to the assembly. There's some other things I didn't touch in the video, but I touched on all the main things that'll kind of help you get going and really understand what you're doing. Now, this might seem really hard to remember all of this and understand it all, which is why I created this mouse pad. Now, this is meant to be kind of a tutorial or a reminder, a cheat sheet for beginners who are first starting out and want to go through their CAD journey. So people who want to start designing but kind of don't know where to start or are kind of lost, I created this. It's basically just a little guide. I already went through my tutorial on all these different sketch tools and all the different commands in the Part Studio. So today we focused on the assembly. And these are just basically like little reminders of the different tools in the assembly. So as you can see here, we got a linear pattern. It tells you the command to do a linear pattern. It kind of gives you a short description of what it does. And yeah, these are honestly like super high quality, but yeah, you don't have to buy one, but you can if you want to. I feel like it's a great way to get into CAD design and start making things. So thank you guys for watching to the end. If you guys want to watch part 1 or 2 of this series, you guys can. Basically, I just walk you through how to create different sketches and how to create different part studios, and that can be helpful for so many things. If you want to get one of these mouse pads, you can find it with the link in the description. Bye-bye.